for you and his broken, suffering arm. In the meantime, we're hoping you're getting better. All right. Thanks to Marta, we now made sense of this. So we're going to go over the basics again. So for A, we just had to use the sum of the roots, right? They gave us the three distinct roots right here, and because there's two imaginaries, if one is di, the conjugate must be minus di. And the sum of the roots is equal to, Marta? It's in your formula booklet.
Yes.
It's in the... It's minus...
A base n
Ace of n minus 1
ace of n minus
over
1
ace of n. In this case, ace of n minus 1 is the second coefficient. It's always the second coefficient. In this case, it's minus 3 over 1. That's 3. And this is equal to log base 2 of A plus log base 2 of B plus log base 2 of C plus di plus minus di. That's equal to 3, which means log base 2a plus log base 2b plus log base 2c is, that's equal to 3, not minus 3, is equal to 3. So log base 2 of a, b, c is equal to 3, which means that 2 cubed equals a, b, c. 8 equals a, b, c, which is what we were asked to show. All right, part B. Part B, we wanted to show that one of the real roots was equal to 1, given that A, B, C are consecutive terms in a geometric sequence. Now, since we don't know where in the sequence they are, I'm going to say that A equals to A to the R, B is equal to A to the R, N. B will be A to the Rn, A will be A to the Rn minus 1. This should work for any n's you choose as long as the n's are consecutive. So if you wanted to start at n plus 3 and minus 3, or n plus 3, whatever you wanted to choose, as long as these powers here are consecutive and abstract, it'll work. Okay, so if we've got that, these are consecutive, and we're told, then we know that ABC equals 8, which we just found. Therefore, A times Rn minus 1 times A r to the n times AR to the n plus 1, not 2, there we go. That's equal to 8. Now, A times A times A is A cubed, and then here, I can just add up all the powers. This is A cubed R, so n plus 1 plus n minus 1 equals to the 3n. I'm going to take the cube root of both, so we get A times R to the n is equal to 2. Now necessarily, in our sequential things, one of the roots is going to be log base 2 of AR to the n, which is log base 2 of 2, which is 1. So we have shown, therefore, that one of the real roots must be equal to 1. Now we're going to move on to question C. And this time, I'm going to multiply complex numbers correctly. Minimize that. Okay, so we know that Q equals 8d squared. And I'm going to use the product of the roots, because Q right here is the constant term. And the rule for the product
is minus 1 to the power of n.
Equals minus 1 to the n. Ace of 0.
And over ace of n.
Ace of n. And ace of n right there is our Q. So minus 1, because it's to the 5, Q over 1. And that's the product of the roots, and we're told it's equal to 8d squared. Well, the product of the roots is log base 2 of A, log base 2 of B, log base 2 of C, times di, times minus di, equals
Minus q.
minus q. Minus q. Okay. D times d, so this is minus d squared I squared, which will be minus d squared times minus 1, which will equal d squared. I just had the experience of going too quickly and forgetting the minus, so I would recommend that you take the time to get it right. Okay, so this means, that this, therefore, because q is equal to 8d squared, minus q equals minus 8d squared, that means log base a times log base 2 of a times log base 2 of b times log base 2 of c should equal to minus 8. Okay. Now, we also know that one of the roots, of which these are, is equal to 1. So now we're simplifying our problem a little bit. This means that I'm going to choose log base a as the 1 log base 2 of a. Log base 2 of b times log base 2 of c is equal to minus 8. Very well. The difficulty here is that they're not in the same terms, and I don't really have much. But if we remember what we just found right here, we had that log base 2 of a plus log base 2 of b plus log base 2 of c is equal to 3. Since log base 2 of a is equal to 1, I'm going to try and rewrite one of these terms, log base 2 of b or log base 2 of c, in terms of the other. So log base 2 of a plus log base 2 of b plus log base 2 of c is equal to 3. One of these is real. I'm going to choose this one. Okay. So that means that it's equal to 2. C is equal to 2. And now I'm going to be able to rewrite log base 2 of b in terms of log base 2 of c. Therefore, log base 2 of b is equal to 2 minus log base 2 of c. Why have I done this? Well, this should help me resolve this question, at least with only one unknown. So now I can write log base 2 of b as 2 minus log base 2 of c times log base 2 of c. And that's equal to minus 8. I'm going to minimize this so that we can kind of work it out to give us a little bit more space. Okay, I'm going to minimize this right here. You know what, let's take everything. Okay, and so let's resize this. All right, so once we're here, I'm going to just expand this out. So we 2 log base 2 of c minus log base 2 of c, and this is squared, and that's equal to minus 8. This is going to look like a quadratic. I'm going to let log base 2 of c equal u. Okay, so this is therefore 0 equals u squared minus 2u minus 8. 0 is equal to u minus 4 times u plus 2. Therefore, u equals 4, u equals minus 2. Now, remember that u is log base 2 of c, so this right here is not a possibility. Take that back, yes it is. Okay, so log base 2 of c is equal to 4, or log base 2 of c is equal to minus 2. Therefore,